This is a short video on marking of a discontinuity using surface distance and reduced surface distance. I'm using a 45-degree probe, and after calibration the index point is marked on the probe. A sticker is also affixed on the top of the probe where the same index mark is extended. And the index point is measured to be 13 millimeters in this case. We will try and locate the 1.5 mm side drill hole on the V1 block. This is the indication. The surface distance that it shows is about 16 millimeter, 15.7 or 16 millimeter. Now we will directly mark above the hole. We will also mark the index point on the block. And if you measure between them, that would be 16 millimeter. Now if you engage the 13 millimeter index point in the instrument, then the machine will automatically calculate the reduced surface distance, and it will show you that value. In this case it would be 3 millimeter. You can also measure from the top of the probe, provided such a marking is available. For any reason, if the sights are not visible to you or the marking is not available on the top of the probe, then the next option would be to measure from the front of the probe. That is nothing but the reduced surface distance. Let us try on this 50 mm diameter hole. The same probe is used. Now the signal can be maximized. So once it is maximized, hold the probe in position, gauge the signal, and read your surface distance and beam path. Let us also insert the thickness of this material. That's 100 millimeter, being V1 block. So now it shows you the surface distance as 53 millimeter and the reduced surface distance as 40 millimeter. So maximize and hold there. Now you can place a mark on the block where the index point is, and then using a tape measure, measure 53 millimeters from there. That's 53 millimeter, and mark on the block. Let's draw a straight line there. This is the point where the beam hits the hole. If you connect these 2 points, that would be the beam path. If the surface distance is measured from the center of the probe or from the index point, then it would be 53 mm. If you want to mark the location of a reflector, this can be used. If you have access to the top marking of the probe, then the tape measure may be used to correctly mark that 53 mm on the material. If that is not possible, then you may also measure the 40 mm distance from the front edge of the probe. That would be your reduced surface distance. In both cases, it would show you the location of a defect, and you can mark that. The reduced surface distance in this case is 40 mm. If you enter the exhaust distance, then it will give you the reduced surface distance. Otherwise, both values would be same. Any of these technique may be used to mark the location of a flaw on the material surface. Thank you for watching.